Crossplane is becoming a real contender in infrastructure as code. It helps solve the pain of tickets, drift, state files, and I'm looking at you, Terraform, and scattered cloud workflows. In this crash course, you'll learn how Crossplane turns Kubernetes into a control plane for self-service infrastructure. We'll cover providers, compositions, GitOps, and real cloud resources in addition to what's new in version 2.0. Let's dive in. In episode 1, we're going to talk about why platform engineering matters. And to start us off, let's talk about the infrastructure problem. And this is where the platform team is really drowning in requests. So you might have a flow like the one on the screen here for a developer that needs a database. They first file a ticket, then they wait 3 or 4 days. Then maybe they got the wrong configuration. They go ahead and file another ticket. They wait again and on. And you might get your database in a couple of weeks if you're lucky. Also, the daily reality is that developers spend 30 to 50% of their time waiting for infrastructure and having to deal with infrastructure. So things like AWS Console for some resources, you might be looking there. You also might be using Terraform for other things. CloudFormation for some legacy work in AWS. A different CLI per cloud. Manual approvals everywhere. So that's the daily reality that developers have to deal with. And we want to make developers' lives easier through platform engineering. So what does platform engineering solve? We have a few problems on the screen for you. The first is ticket queues, and we solve that with self-service infrastructure. You also have inconsistent configurations that you might run into, and we solve that with golden paths with some reasonable defaults. You might also run into cloud complexity, and we solve that with abstraction layers. And then finally, knowledge silos, and we solve that with platform as a product. So what is Crossplane? Well, it's a Kubernetes add-on for your infrastructure. It will turn your cluster, that's the Kubernetes cluster, into a control plane. It's declarative, API-driven in its approach. You get continuous reconciliation, auto-healing, and you don't have to worry about drift and the issues that come with drift. And also, there's no state file to have to manage, like the case with Terraform. You manage cloud resources just like you would normally manage your application resources using kubectl. And eventually, you're going to go and use Argo CD or Flux in a GitOps pattern. Quick comparison between Crossplane and some traditional infrastructure as code tools like Terraform. So the first thing with traditional infrastructure as code tools is that you get a lot of separate tools. You have to use Terraform with Ansible and so on. Manual drift detection, that's an issue. If you're using Terraform, you need to run Terraform plan manually multiple times, or you might want to automate it, but it gets really complex fast. And then you have state file management. So the state file for Terraform, you have to find a way to secure it and manage it properly. And then different workflows you might run into as well. With Crossplane, it is Kubernetes native. So if you're a Kubernetes shop, you'll feel right at home. There's automatic reconciliation, no problems with drift. Kubernetes etcd is where basically the state lives. So it's using that as a database. There's no files to worry about. And then you use Crossplane similar to how you configure your applications or run your applications. All is done through Kubernetes native tools. In this episode, what we're going to demo is how to install Crossplane on Kubernetes. We'll explore the CRDs that are created. CRDs stand for Custom Resource Definitions. And then we're going to look at setting the CLI tools and finally configuring multi-tenant RBAC. So let's go ahead and jump into our demo. But before you go anywhere, by the end of this video, we're going to see what we'll cover in episode 2. So stay tuned. Just a quick plug before we continue. This video is part of my Crossplane 101 course where we dig much deeper into Crossplane and how to build your real internal developer platform. We cover Kubernetes cluster setup, AWS provider integration, compositions and XRDs, packaging and deployment, GitOps operations, Crossplane version 2 migration. And the course includes over 15 hours of video and 7 hands-on labs. You also get a certificate at the end, and you also have a 30-day money-back guarantee. If you're interested, check it out in the description below. All right, let's get back to our lesson. We're here in the Academy, and let's jump into our Crossplane 101 course. Continue learning. And we're interested in jumping straight to our first lab here, setting up your Crossplane platform. I already started the lab, so we can jump in and enter the lab right away. And what we're going to do, if you look at the progress here, we're going to start the Kubernetes cluster with Minikube in this first task. Then we're going to install Crossplane with the production config. And then we're going to configure platform engineering RBAC. So let's go ahead and get started. Step 1, start Minikube cluster. So let's clear here and let's paste this. What this will do, it will go ahead and start Minikube with 2 CPUs. And let me just make this a bit bigger. And we see the Kubernetes version 1.32 driver Docker. So give this a minute or two until we're ready to go. All right, looks like it has completed. So we can run the kubectl cluster info command here. And yes, it looks like everything is running nicely. You can see Kubernetes control plane running at this address here. Core DNS is running and so on. So clear that. Let's verify the cluster health. So a bunch of commands here to make sure that is working well. kubectl get nodes. We only have one node running well. And again, version 1.32.0. We can also check the kubectl get pods with the kube system. So we have a bunch of pods running here in kube system, all standard for Minikube. And you can also verify that you can create resources by running this command, which is really helpful when it comes to checking against RBAC. And then we can create some namespaces for platform engineering. So we can go ahead and create a Crossplane system namespace. And we can create a namespace for a platform team. And maybe one for a backend team. And one for a front-end team. If you run kubectl get namespaces, you'll see all the namespaces created right there. And you can also run this command kubectl get all against all namespaces. And this will show you the pods running, also the services, the daemon sets, if there is any deployments, replica sets. So it gives you everything in kind of one command. Again, it's against all namespaces. All right, so we're good to go, and we are ready to go ahead and move on to the next task. So again, in this task, we're going to install Crossplane with production configuration. Let's clear here. And first step is to add the Helm repository. So let's do that. Do a repo update. Let's search for the Crossplane Helm chart. It's right there. We can create a Crossplane values file. And we can create this file in the scripts tab right here. And let's give it a name, Crossplane values.yaml. And copy that and put it in there. So this is the values file that we have here. So you can see what image we're going to use, resources, security context, and a few others. Now we can install Crossplane with this command. So change directory into the scripts folder and then run the Helm install command like that. This wait flag makes sure that it will wait until Crossplane is fully deployed. And once that's done, it takes about half a minute or a minute. We'll be able to check for ourselves. All right, this looks good. Let's change namespace into Crossplane system. And now let's clear and run Helm ls or Helm list. And from here, we can see that we have our Crossplane chart running here, and the app version and everything else is good. You can also run kubectl get all. And you can see that it installed 2 pods, an RBAC manager and the main Crossplane pod. We have a service, and we've got the 2 deployments here with the 2 replica sets. So this all looks good. Next, we want to install the Crossplane CLI This helps with debugging, development, managing crossplane resources. I like it quite a lot when we're debugging specifically and running some monitoring commands. So you can run this script right there, change permissions and move it to this location. And now you can just simply run the crossplane binary. Here's crossplane version, shows you the client and server versions, which is perfectly what we want. Finally, step 5, let's explore some resources. We'll explore the custom resource definitions. So let's clear here so we can see it better. Here's a bunch of CRDs that got installed with the Helm chart from Crossplane. So you can see composite resource definitions, composition revisions, compositions, configuration revisions, configurations, and so on. So all this we will use with Crossplane. You can also run kubectl get providers. You can see providers here is a custom resource definition. So this didn't exist before we installed Crossplane as a Helm chart, and that's what Crossplane is. It's an add-on to extend Kubernetes. So now we can use Crossplane to start to create resources in AWS, on-prem, in GCP, and so on. So here we can see that we don't have any providers as of yet, but all I want to show you is that these custom resource definitions you can use directly, just like you're looking up pods or deployments that are native to Kubernetes. You can now do the same thing for Crossplane custom resource definitions. So that is all I wanted to show you in this task. We can jump on to the next task, where we're going to create some RBAC, which is typically what you want to have when you are running Kubernetes in production in general. And from a platform engineering perspective, you want to have different roles. So we'll see that right now. The first thing we want to do is create a platform admin role. So we can go to the manifests folder here, and let's create a new file, and we'll call this file platform admin role.yaml. And in here, we're going to paste this Kubernetes manifest. It's a cluster role, and you can see the full Crossplane permissions, Kubernetes cluster administration as well. Here's all the here's the policy that will allow us admin access. All right, now let's go ahead and create a cluster role for the platform operator. This is a new role, so new file, new manifest. We'll call this platform operator role.yaml. Let's copy that again, put it here. As you can see, this is a new role. And time, instead of showing everything here, we were allowed to do pretty much almost everything. Here we are restricting it a little bit more. So you can see the restrictions in here, what we're allowed to do, what API groups, what resources. It's another role. And now we can also add developer team roles as well. So we can create a new file for a new manifest. This one, we're going to call it, let's see here, Crossplane developer role. And just copy this right here and create the file, create, copy our manifest, just paste it here. All right, you can see what this role allows. And now we can actually create, instead of a cluster role, we're going to create a role. Cluster role applies to the entire Kubernetes cluster, and a role can namespace, so it applies to a specific namespace. In this case, we created a Crossplane developer role here. Now we're going to create a backend team developer role. So new file, backend team developer role. Copy that, put it in here. There you go. So it's tied to the namespace backend team, and this is what they're allowed to do in here. And once we've defined all these manifests, we want to apply them, right? So this is a declarative product, which is Kubernetes, and we want to be able to apply everything we've just created right here. So all the different roles that we have, 4 of them, we're applying them one by one. Let's verify that it all got created with the kubectl get cluster roles. You can see 3 of them had cluster roles, and there's only one that is just a role, which is the backend team. All right. So far, we just created roles. These are policies, but you don't really do anything unless you create service accounts that can reference these roles for the permissions that you allow. So let's go ahead and create some service accounts. We're going to create one service account here for the platform admins in the platform team. And we can create a service account for the platform operator and one for the backend team. And let's create one for the front end team. Let's check the service accounts were created for the platform team. You can see here we got the platform admin, platform operator, and the service account for the backend team. And finally, a service account for the front end developer and the front end team. Now, these are service accounts, but they have no permissions, right? So they need to be tied to the roles or cluster roles that we created. So we need to create something called cluster role bindings. We can do that by creating a new file, and we call this role bindings. So we're binding the service accounts to the roles that we created, whether they're cluster roles or just simply roles. So this is a cluster role binding, which will bind a service account to cluster roles. So cluster role binding, as you can see here, we've got the service account platform admin is tied or bound to the cluster role platform admin. And the platform operator is bound to the platform operator, the service account to the role, the cluster role, and then the backend developer to the Crossplane developer. And finally, a role binding here for the backend team with the backend developer to the backend team developer. So that should all be good to go. And you can, in Kubernetes, if you're familiar with Kubernetes, you can, of course, add multiple manifests in one file. This is just simply YAML, and just separate them with these 3 dashes. And then once you do that, we can just run one command that will take care of deploying everything for us. So you see 4 manifests were deployed, 4 objects were deployed for us. Let's clear this and take a look at the cluster role bindings that we created. So you can see 3 of them here, and then we have 1 role binding that we created as well. All right, that's all good. Now let's go ahead and test all this, right? It's nice that we've created it, but there is a way to test it. I kind of alluded to that in the beginning of this demo, but you can run this command kubectl auth can I access everything here as a system service account platform team? And the answer is yes, which is good. Let's go ahead and run this command. Can I create providers as a system service account team platform operator? Yes, so that's good. And then let's try something that will show us a no. In this case, can I delete nodes with the service account platform team platform operator? And in this case, it's a no. Here's another test. Let's see if we can test whether a developer can create pods in their own namespace. So this is accept. So you can see create pods in the namespace backend team with the service account backend team, backend developer. So that worked. Here's another one. We want to test, see if the developer can create crossplane providers. In this case, they cannot. Okay. And one more. So test if developers can or cannot access other teams' namespaces. In this case, they cannot as well. And really, that's what I wanted to show you from an RBAC perspective. So as you're building your internal developer platform and providing that to platform engineers and developers and anybody else on your team, you need to have these roles in place. You need to have those bindings in place and RBAC set up in a way so that people don't step on each other's toes and everybody has the work that they're allowed to do. And that is what I wanted to show you here, because again, this is a platform that you'll build and providing it to your application developers and also your infrastructure team. Welcome to episode 2. So let's go ahead and get started. The provider model. Providers extend Kubernetes API with cloud resources, similar to what we've seen with Terraform providers. We have the same idea here. The AWS provider adds over 1,000 resource types. Each resource becomes a Kubernetes object, and it's the same pattern with other cloud providers or even on-prem resources, so Azure, GCP, and so on. And then kubectl becomes your tool to interact with your infrastructure. So for example, kubectl get VPC will show you all your actual AWS VPCs. How does Crossplane manage resources? First off, you create a YAML manifest, then run kubectl apply, and then Crossplane will kick in and it will go and create your AWS resources by talking to the AWS API. Crossplane continuously will monitor and reconcile your infrastructure and automatically detect and fix any drift that might happen. So if anyone makes a change in the AWS console itself, it will detect that and it will revert that change. What are we going to build in this demo? We have VPCs that we're going to create, subnets, internet gateway, route tables, and security groups. All will be managed through Kubernetes. We'll see the power of reconciliation in action. So drift is detected and fixed automatically. You don't have to do anything. Comparing this with traditional infrastructure as code tools like Terraform, you would need to run Terraform plan, run Terraform apply, and then hope no one changed it. With Crossplane, this is done for you out of the box with no manual interaction that you have to do. And this is thanks to Kubernetes internal reconciliation. So Crossplane is basically using that. So if you recall with Kubernetes, if you go in and delete a pod, if the pod is part of a deployment, for example, Kubernetes knows that your intent is to have this pod through the deployment. So the deployment will go back and recreate that pod you deleted. So it's the same idea now with infrastructure through Crossplane. So what are we going to demo? We're going to demo how to install AWS providers, how to configure secure authentication, how to create VPC and networking, and watching drift detection working in action. So let's go ahead and get started to build. But remember, at the end of this video, we're going to give you a sneak peek of what's to come in episode 3. Here we go. We are in our Crossplane 101 course and in section 2 and the lab here, AWS Cloud Resources with Crossplane. I already started our lab for us, so we can enter. And I actually also went ahead and skipped the first task here. As you can see, we have 4 tasks. So the first task was just to get everything set up. So I'll walk you through that real quickly. Step 1 is to verify the pre-configured Crossplane environment. So Crossplane, as I said, is a Kubernetes extension. So we can see the pods here running for Crossplane. That's all good. And also, if we go down here and look at the providers, you'll see we have 2 providers that are healthy, the AWS EC2 and the family AWS. That is what we're going to use. And to install it, we create a manifest like this. So you can see this manifest in the manifests tab here. We have the provider manifest right here, as you can see, of kind provider. And we also need to apply it. So you use kubectl to apply, just as you're used to. And then you can also see the CRDs that get generated. So if we run the command here, clear, you can see the different CRDs that are available here, as you can see. We can also, or need to, create the AWS credential secret, because this is how Crossplane is going to be able to access AWS. We can verify that the AWS configure list is available here. And this is part of the lab. When you start the lab, it will create an AWS account for you and will give you the secrets that you need to put in for Crossplane. And you can see here, create a secret containing your AWS credentials. So you can run this. We already ran it. So if you run kubectl get secrets, you should see the AWS secret here. You can also see the content, decrypting it, and you can see both the key ID and secret access key right here. Then you need a provider config for authentication, right? So you need to tie the secret into this provider config. So once again, in the manifest AWS provider config, you can see here we have our source is secret, namespace crossplane system, and then the AWS secret that we just created, applying that as well. And you can view the provider config, or you can describe it. Once again, the note here is to see how everything is done using Kubernetes, right? So if you're a Kubernetes shop, you'll feel right at home with Crossplane. So that was the first task. The second task was to test our providers and authentication. So we can create our first AWS resource, and that is simply by going to manifests, and we can copy this and create a new manifest, and we call this one test VPC .yaml. And let's go ahead and paste our manifest in here. As you can see, kind VPC, which is interesting because now we are using the extension, the CRDs from Crossplane to create infrastructure. So we're creating a VPC in the region US East 1, the CIDR block right here in front of you, enable DNS host names and DNS support is true, a few tags, and then we're calling the provider config default that we just created. We can go ahead and apply that. So if you go back to the terminal and clear and run fly, that got created for us. And once again, you can run describe if you are interested in seeing this in action. Now we can go ahead and verify in the AWS console that the VPC got created. So the way we can do this is we can open the AWS console tab here, and we're going to need our username and password that was created for us. So if you click on open in AWS console, and then we just need this username, and then back here, it should give us our password, and put our password in place here and sign in. Just make sure that we're in the US East 1 region, because that's where we created that VPC. And now we can go ahead and search for VPC. And here we go. We got 2 VPCs, and we see our Crossplane test VPC right here with the CIDR block that we configured and the tags that we put in place, and all looks great. Now let's demonstrate Crossplane's reconciliation. So what we can do, we can select this Crossplane VPC and edit it, and then change the enable DNS host names to disable, and then save the changes. And then we'll see how this will get reverted and how Crossplane is going to bring it back. So edit VPC settings, enable DNS host names. Let's look into that. Edit, let's see, VPC settings, enable DNS host names. Let's remove that and then click save. And DNS host names is disabled. Now, if we wait a little bit, we'll see how this will bring us back, or Crossplane is going to bring it back. So I'll pause the video and wait for this to trigger, because it can take a little bit of time. But you can also run this command, and you should be able to see synced status briefly. We might be too late, but either way, we'll see in just a second or two how the Crossplane will revert back that setting that we changed outside of Crossplane. So we're simulating drift, basically. All right, I see some changes at the bottom here. Well, it looks good. So let's go into our, oh, there we go. Enable DNS host names is enabled now. And that is done automatically through Crossplane without having to figure out what has drifted and whatnot. This was all done for us, which really shows you the power of the reconciliation loop. Okay, and that should be good for this task. Let's move on to our next task, where we're going to create a VPC and networking infrastructure. So not just a VPC, we'll do a lot more than that. So first, let's clean up and review the infrastructure files. So you can easily run kubectl delete VPC, and then the VPC name that will remove our VPC. And we can verify that by going to, once again, our VPC dashboard here. And you can see if we refresh, there we go, it's gone. And we are back here. The setup script has already created all the necessary manifest files for us. Take a few minutes to review those. So if we go to manifest, you can see the setup script for this task has already created a bunch of configuration for us. So this was our test VPC that we saw earlier. We see some security groups now. You can see the resource kind here, security group. Okay. And we see another security group. And then these are some security group rules that match, use a match label to match the security group. And then we have an ingress rule for port 80 to port 80. Region is US East 1. Here's another web HTTPS ingress for port 443. Here's one for port 8080. We have some public subnets that got created as well, kind subnet. And you can see we have a selector for the VPC. So we need to attach the subnet to a particular VPC. So we're matching that by label, as you can see here. And here is, so that was public subnet. This is another second public subnet. And here are the private subnets. So we got 1, 2, and then we've got the platform VPC. This is the new VPC, not the test VPC. So this is a more advanced VPC, as you can see here. And then an internet gateway as well. So you can see the internet gateway. And once again, VPC ID selector, we're matching by label. So tying this internet gateway to the VPC that we created. And then, of course, the EC2 provider and AWS provider config. So now we just need to deploy. So now that we've reviewed everything, we can go ahead and go back to our terminal and apply the VPC configuration. And notice we are going to apply and pretend that we are the platform team. So when this lab was set up, it was set up based on what we did in episode 1 with RBAC. So we have all the RBAC in place, which is what you need to do in production. So then when we're deploying the VPC in this case, we're deploying it as a platform admin, as part of the platform team. We can now wait for this VPC to be ready. Condition is met. Excellent. And notice now we're running kubectl get VPC and the name of the VPC, and we can see that it's synced and it's true. Again, we're using kubectl in our commands. And now we want to add internet connectivity, so we can run this command for the internet gateway. And we can wait for it as well. Okay, it's done. You can look it up. It looks good. And now we want to create the public subnets. So we'll run this command and we can wait for it. So that created subnet 1A and subnet 1B. We'll wait for them to be ready. Subnet 1A is ready. Let's check on subnet 1B. That one's also ready. And we can check the subnets using kubectl get subnets. Looks good to me. And then we can create the private subnets similar to what we did with the public subnets. And again, wait for them to be created. Subnet 1A is created and subnet 1B also. Now we can create security groups. Run this command. And we got 2 security groups created, so let's wait for them. This is the platform web and then the platform app. Perfect, they're both created. And now let's go ahead and look at step 7, where we are applying the security group rules that are tied to the security groups that we created. So that's the HTTP ingress, and it's done. Let's look at the HTTPS ingress, that's done. And then let's look at the web ingress. That's also complete. We can verify everything here with all these commands. We can also use this Crossplane beta trace command, which is one of my favorites. It will make a lot more sense when we use it with the compositions. In our next episode, we'll see that. But you can see that these are all synced and ready, which is great. And once again, we can jump into the AWS console, look at VPCs, subnets, internet gateways, security groups. So let's go ahead and do that. So refresh the VPC, a new one should show up. There it is, platform VPC. As you can see, it's right here. And it has a bunch of subnets with a routing table. And we also should have an internet gateway right here. There it is. And some route tables that we saw. And here are subnets, some public, some private, and then security groups. Here are our security groups, platform web, platform app. If you click on one of these, you can see it has HTTP and HTTPS rules. So that all looks great. And now we can just delete the work that we did. And once again, you can delete it with the kubectl delete command. That's pretty much what we'll probably be doing in the next task. So let's go ahead and do that. First, let's make sure that we did everything correctly, and we did. Now learn how to properly clean up all the AWS resources we created. So review the current infrastructure. You can use this handy command where you can run kubectl get VPC, subnet, internet gateway, everything in one command. It will show you everything at once. Now, before deleting resources, you need to understand the dependency order. So you can see here, this is the hierarchy. Always delete in reverse dependency order to avoid errors. So you can see security group rules, they depend on security groups. Security groups depend on VPC. Subnets depend on VPC. Internet gateway depends on VPC. And VPC is really the base resource, should be deleted last. Okay. So let's go ahead and start deleting. You can delete the security group rule. Make sure it's all deleted. And there it is. Delete the security groups. Let's delete all the security groups like that. And verify that it's gone. Delete network components. So all the subnets, the internet gateway. We can check on both. No resources. Looks good. Finally, we can go ahead and delete our VPC. And now if we run this command, it should show no resources found. Perfect. And if we check on all our resources in AWS, in the console, go ahead and refresh. There you go. VPC is done. It's gone. Routing tables, these are the default ones. So our routing tables are gone. Subnets, let's refresh. These are gone as well. Internet gateway, refresh. That is also gone. Good work. So that pretty much concludes our demo. And again, we were able to create the resources in AWS using Crossplane. And we saw how we're able to make use of the reconciliation loop. And we saw drift detection being reconciled automatically. Welcome to episode 3, Developer Self-Service. In this episode, we're going to talk about the abstraction problem. The current state today is developers need to know a lot of infrastructure concepts, which really is not necessary. They're not infrastructure engineers. So things like AWS networking concepts, CIDR block planning, security group rules, resource dependencies. In reality, all they need to know is that they need a database, for example, in a production environment and maybe size medium. So you can see here 4 lines of YAML that should go out and trigger everything behind the scenes from an infrastructure perspective. And they should get their database self-service without having to issue tickets to the infrastructure team. Now let's talk about the composition model within Crossplane. We have 3 components, and this will be down to 2 components when we talk about version 2, because claims disappear in version 2 of Crossplane. But for version 1.x, we have the composite resource definition, and this defines your platform API. The composition, this maps API to resources, and your claim, this is what the developer uses to request the resources. XRD, think of it as a menu when you're ordering at a restaurant. Composition is the kitchen, and claim is the order that you submit. One claim, many resources. Again, the developer requests something very simple like a database, and that goes behind the scenes and creates a number of resources. We'll see in the demo, 13 resources will get created We'll have a VPC with networking, public and private subnets, internet gateway plus routing, security groups, and RDS database instance. Let's talk briefly about composition functions. This is where you need some advanced logic, so maybe conditional resource creation, environment-specific configs, array-based resources, dynamic feature toggles. So you ask these questions. Maybe basic compositions are not enough. They are powerful, but you need a little bit more when it comes to conditional logic and you don't want to repeat yourself. What if you want versioning only in production? How do you achieve that? Or what about different storage tiers based on what environment you're deploying to? So that's where composition functions come into play. What are we going to demo? We will see how to design the XRD schema, how to build a composition, how to create a claim. We'll watch 13 resources cascade and get created, and we're going to connect to the database. So let's go ahead and start building. But remember, at the end of this video, you'll see what we'll do in our next episode. Let's start this first lab here where we're going to talk about platform abstractions with Crossplane. So this is found in section 4 of our Crossplane 101 course. Here's our lab. And I already ran this lab and skipped a couple of tasks. But basically what you'll learn is how to create XRDs. These are Crossplane resource definitions. And we're going to do this for our database services, and also how to build a composition and a claim, and how that is going to go ahead and create all the real AWS resources for us. And once again, think of personas. So the platform engineer is going to build the XRD and composition, and then the developer is going to write a claim, which is very simple, that will create all the AWS resources behind the scene. And then at the very end, testing and validating our platform by actually connecting to a database. Let's go ahead and enter our lab. As I said, we have 3 tasks here, and I already skipped our first 2 tasks, but let me go back and show you what has been done so far. So in step 1, we're just validating that we have a platform that's running here. So we've got our kubectl get pods. You can see Crossplane is running. We have providers also running. So if you can check here, you'll see we've got the AWS EC2 and AWS RDS. And of course, the family AWS comes for free with these providers. All right. Then we created an AWS credential secret. This is obviously needed so that you can connect Crossplane to AWS. So let's check on that secret right here. It's called AWS secret. And we've already installed AWS providers. I showed you that. And we've seen that in the previous episodes as well. So you can see this is the outbound provider AWS EC2 and the outbound provider AWS RDS. These are all found in our manifests here. So we copy that over and then we just apply with kubectl apply as we're used to. All right. And then we have our AWS authentication via the provider config. So we have our provider config right here. This is what ties the secret that we created to that particular provider. So we're able to get Crossplane to connect to the AWS API. And then finally, this is what's new so far in this lab, and that is creating that XRD file. So if we look at our XRD file, it is over here. And as you can see, it's of kind composite resource definition. Give it some labels. And here is our spec. So you can see the kind X database in plural and claim names. So this is the schema that we're using to provide our composition with what exactly we're going to build. So you can see here is the schema, Open API version 3 schema, environment. We can choose from dev, staging, production, database size from small, medium, large, database name. There's a pattern to follow. So name of the database to create, storage in gigabytes, minimum 20, maximum 1,000, and a default. Network tier, public and private. Default is private. Connection secret namespace, where we're going to be able to get our connection details for the database. which fields are required, and so on. So this gives you a feel of the schema that we're working with, that XRD, and that is really what we talk about in this task. So once we create the file, of course, as usual, we apply with kubectl apply, and you can verify the creation with these regular kubectl commands. So we can run kubectl get XRDs. You can see it's right there. And you can also describe it as well, which will give you what we just saw in the manifest. All right, so this looks great. We can check the generated CRDs as well if that's of interest. So if you clear out of here and run that, you can see the database claims and X databases that we just created all ready to go. So the composite resource XR that platform bins can manage is this X databases. And then the database claims, the claims that developers can create in their own namespaces. Now here we can test the schema by creating an invalid claim and see how that will work. So we have a manifest here and we have a test claim. Let's see, did we create it yet? No, we haven't. So we can create that. A new file, invalid test.yaml. Create that. As I said, we can put the kind database claim. So this is what a database admin or a developer would request. You see here 9 lines of code. That's it, right? And we are requesting environment called invalid env. This should fail. Size tiny, that should fail. And database name. And with that, we can go ahead and try to deploy that with kubectl apply. And as you can see, we're deploying this as a backend developer and just the name there. And you can see right away we get an error. So unsupported value, and it gives us what the supported values are, and unsupported value again for the environment with what the supported values are. And the reason why it knows what they are is based on the schema in the XRD that we just saw. All right, now let's jump into our next task. And this task, we're going to look at building the composition. So creating a basic database composition. Here's just a big disclaimer that in this case, for demo purposes, we're building a database that is publicly available on the internet, which is a big no-no. Do not do this in production ever. But for the sake of just a lab and a demo, that is fine. So we're going to go ahead with that. And here is a composition file. As you can see, we have also created that. But notice that, again, the kind is composition. So the composition file is here, database composition. And this is a rather large file. And again, this is fine. This is the platform team that takes the brunt of this, about 500 and something lines. And in here, you'll see that we are creating different resources. So here, for a database, we need, I think we said 13 resources. So VPC is one of them. And in the VPC, you can see how we're defining this. Here's our base, a bunch of CIDR block, a bunch of properties here, like enabling DNS host names, enable DNS support, what region we're in, some patches that we require. And these patches are similar if you're familiar with Customize with a K, and that will be very easy for you to understand what we're trying to do here. But basically, we can have a sort of a default set of properties, and then we can patch these properties with parameters that you can take from the claim and feed that in. Okay, so there's more to be said about that. I'm not going to get into the details of this, but just know that this is a way for us to customize our composition. So you define it once at the bottom, these patch sets, and then we can feed it into the different resources multiple times, like tags, for example. So patch set common tags is defined at the very bottom here. And these are tags that we want for all these resources. So we can just patch it or patch each resource with that same common tags patch set. And so on and so forth, right? All right, moving on, let's continue here. You can see overriding name tag as well. So we can override specific name tags, overriding these common tags patch set. And here we are creating a private subnet for the database. So database subnet 1, CIDR block, and so on. We have a private subnet 2 And then we've got a security group, and we've got another security group. Actually, this is a security group rule for Postgres. And then we've got a security group rule for all outbound traffic, and then internet gateway, a routing table, and a route to the internet gateway, and then a route table association, and then a database subnet group. And finally, our database instance here, RDS database instance. And you can see here all the different parameters that we're building for our database. And then there are some environment-specific configurations using map transforms. I won't get into the details here, but they are available to you in the course. And here are our patch sets at the very bottom. And that basically bundles all our resources into this composition so that when the developer requests with a claim, all of this gets created, as opposed to what we saw in the previous episode where we created each AWS resource separately and not as part of a composition like this. So you can think of this, if you're coming from a Terraform background, kind of like a module. You're, again, packaging all these resources together. Not exactly like a module, but kind of. And then once we've defined this composition, we go ahead and apply it as usual. And we can check on it as well that it's been created with the kubectl get composition command. And there it is, X database. It is available to us. Now we can create and test database claims. We kind of created one that was invalid in the previous task. Now let's create one that actually is valid. And this actually was created for us already here, called test claims. And as you can see here, we've got 2 claims, and they're both of kind database claim. And we have some metadata here. The name is dev app DB and staging app DB, and they're both in the backend team namespace. Some specs here, we've got the environment dev as opposed to environment staging here. Size small, size medium. Database name is test app. This one is staging app. And then writing the connection secrets to namespace in the backend team for both. This is again what will allow us to connect to our database once everything is done and complete for us. So we go ahead and apply the test claims. We've done that. And now we can check on these claims by running this command. And notice that this command is associated with the backend team here. And as you can see that the dev environment database is synced and ready, true. Whereas the staging one is synced but ready, false. This takes a little bit longer than the dev one, and that's fine. So we can wait for that. But notice the difference really is a little bit subtle. You might not see it in the database claim because we're hiding it from the developer. It is actually inside of the composition itself. So we have a few commands that are very useful. I think in the previous episode I mentioned this, but if you run this command, kubectl get x databases, you can see the similar kind of view, but a little bit different. This one is more geared towards the platform engineers, and the other one here, the get database claims in the backend team, is for the database team or the app team. Like I said before, the claims are moving away. In fact, in version 2 of Crossplane, we don't have claims anymore. We'll get to that in our last episode. But again, I'm talking about claims just because there are some organizations that are still running on Crossplane version 1.x. Now, one of my favorite commands here for monitoring is the Crossplane beta trace command. And if you run that, you'll see that we are tracing the dev app DB database claim for the backend team. And it shows you all the different resources that will be created as part of that claim, part of that composition. So we can see the internet gateway is true and ready, the route table association, and the routes, the security group rules, the security group, the subnets, the VPC, the subnet group, and the actual database instance itself. All right. So that is ready. We can check on the other one as well. The other one is called staging, I believe. It's called staging. And it seems like it's already synced and good to go as well. So if we run that previous command here, there we go. It is true. It is ready. So we're all set, and we have both databases in dev and staging working and ready. We can also run this command we saw in the previous episode as well, which gives us all the resources that we're building, right? So typical Kubernetes output, you can see here, the VPC, the subnet, security group rule, the internet gateway, route tables, routes, and finally, the 2 database instances. All right, so if you don't believe me, let's jump into the actual AWS console. And from here, we are going to log in and see things inside of AWS itself. So let's open that and paste this. Let's go get our password and sign in. We are not in Ohio. We are in US East 1. Okay, so first off, we can jump into the VPC and see what's been created. Here we go. We've got 2 VPCs, one staging and one for test. And there they are. And of course, we'll see all our subnets here for test, for staging, route tables, internet gateway, and probably security groups as well will show up here. There we go. So all the networking is in place. Now let's jump into our actual RDS databases and see these 2 instances, database instances. And here we go. We've got both RDS Postgres databases, the dbt3 small and dbt3 micro. One is for dev or staging, one for dev or test, and one for staging. And you can notice sometimes you'll see this identifier shows Terraform because some of the providers that are used do use Terraform under the hood as well. That's part of what Crossplane does. So that is available also. If we click on here, you can see a little bit more details on the tags, for example, that we put in place. And let's go back to our lab. So that looks great. Let's move on to task number 3. All right, in this task, we are going to test and validate the platform. First step is to get the secret, right? So there is a secret that got written in the backend team namespace, one for the dev and one for the staging database instances to be able to log into these instances, right? So that is here, and we can take a closer look. There we go. And then we can export one of those secret names for testing using a dev database secret for faster provisioning. We can run this command. It will export the secret for us. And you can see the actual secret is right here. And we can examine that with this command. So in here, you can see the plain text of that secret, right? So the secret that we're using, which is here, right? So that's the secret name. But this is the actual content of the secret itself. So you can see address, attribute, password, endpoint, host, password, port, all that you need to access that RDS database. So we can test the database connectivity with this command. First off, we'll export the endpoint and then export the PGP password, which are both shown here. Let's run the PSQL command to log into the database. And we have successfully run the command. And you can see here we have the output that we expect from that. And let's create a table and insert some data into it. There it is. There's the table named platform test. And that is excellent. We have successfully created all the AWS resources from a networking perspective, including the database, and also created 2 of these, one for dev, one for testing. So 2 different environments, all that done with 2 claims And those claims went and created everything through the composition that we saw. And from there, we can go ahead and delete everything with one command. So we don't have to worry about the ordering. If you recall in the previous episode, we had to do things in reverse order because we created each resource separate. But now, since we are using a composition and a claim, so we can reverse that by just running the kubectl delete the two database claims that we have, and that is going to go out and delete all the resources for us. And I think the key here to learn is that there are two personas. There's a platform engineering team that deals with the XRD and the compositions, and then there is the database or the app team that creates the claims. So once you have that distinction in mind, things will make a whole lot more sense. We can quickly run this command again, the beta trace command, to see if there's anything there. And obviously the dev app DB has been removed. And if we want to check on the staging one, we can do that as well. And that also has been removed. And we can also check here in the AWS console, go back to databases, and you can see that they are being deleted. In this next lab here in section 6, advanced composition functions, I'm going to briefly go through this quickly so that you know that there is a way to create some more complex compositions that allow us to do templating and if statements and conditions and so on. So let's jump into this lab. And I already ran our first task here, as you can see. So let me walk you through that real quick. Actually, we're in task 1 right here. First off, there's an XRD that got created. We've seen XRDs. So this is just our schema. So that's all done. And then the second piece is where we install composition functions. And we have 3 composition functions here. The first one is called a Go templating function that allows us to create some templates. The second one here is an auto ready function that automatically manages resource readiness status for us, because sometimes it will show, if we don't use it, it will show that the resource is not ready when it actually is ready. And then this last one, the apply, the patch and transform function, this one is similar to what we saw in the previous lab, but this actually is going to be required moving forward with version 2. And you'll see that under here when we talk about understanding these functions. So really quickly, the 2 modes to compare inside of a composition is traditional resources mode and pipeline mode. And again, moving with version 2.x of Crossplane, we'll be using pipeline mode everywhere. So resource mode is what we saw in the previous lab. It uses the resources field in the composition, direct patch and transform operations, limited conditional logic, good for simple static resource creation. And then pipeline mode is for functions. It uses the pipeline keyword here, and functions process requests in sequence one at a time, similar to our GitHub Actions or a GitLab steps and so on. Advanced conditional logic with Go templates, complex transformations and calculations. It's better for dynamic conditional resource creation. Here's a quick explanation of the 3 functions I mentioned. So Go templating, you can put if conditionals and use the usual Go templating language inside of that composition. The auto ready function, again, it just enables some resources that otherwise would not show ready in their status. It will allow that to show ready. And then patch and transform is use it for migrating existing compositions to pipelines, simple field transformations, and so on. So creating your first function pipeline here, really quickly what it looks like. So kind composition, here's the spec, and then notice mode is pipeline. And if we can make this a bit bigger. Steps is how it works. So it goes one step at a time, creating the bucket resource. And the function reference here is the function Go templating. And then you can see here's our template. Here's the resource that we're creating. It's a bucket. So we're going to create an S3 bucket. Tags, environment, and then we have a template function here, or a template variable. observed composite resource spec environment, tier, bucket name. This will all get filled out. We have an if statement, which has an or. So if we have the environment is staging or the environment is production, then we're going to generate this bucket versioning resource. Here's another if statement. If we are in production as the production environment, we're going to add this resource bucket server-side encryption configuration. If we are running with the tier called premium, we are going to add this bucket intelligent tiering configuration as well. So you can quickly see how within the composition, we have this logic that we can create if statements and templating and all that good stuff. And then we apply the composition as we've seen before, kubectl apply. Then we can test the pipeline. So we can create this as a test bucket claim, run that, and then you can examine what the pipeline did. So we can run this kubectl get x bucket like that. And you can see the environment is dev, tier is basic, and it created an S3 bucket. We can quickly see that in the AWS console itself. If we flip over, here it is. This is an S3 bucket that we just created. All right, so that takes care of our first task. We can run the Crossplane beta command because I love it. You can see the test bucket right there, and that got created. And now let's move on to our second task real quickly. So first we need to clean up our previous resources. So we saw that before. We can just run kubectl delete and then the bucket claim or the claim and verify that with this command. Buckets are easy to create and delete really quickly as opposed to databases, which is why I use that for this particular lab. All right, now let's go ahead and understand array-based bucket creation. So we can create multiple buckets at once as opposed to creating one by one. So to do that, we're actually going to need to update the XRD and also update our composition. So we can do that. We'll skip the XRD for now, but here's the composition. And as you can see, it's very similar. The mode is pipeline. And you can see the template here handles single bucket or array of buckets. This is a comment. And I won't go into the details, but just know that the composition will allow us, based on the claim, it will understand the claim, and based on that claim, it will generate an array or multiple buckets at the same time or a single bucket. So let's go ahead and implement this. And I think we don't need to do anything to the XRD. It's already done. Yeah, we can quickly see it here. There we go. You can see the type is array. Now let's update our bucket or create a new composition, I should say. So manifests bucket composition arrays.yaml. Let's create that. Bucket composition arrays.yaml. You can save that. And then apply it and check to make sure it's applied. There we go. Bucket AWS arrays. It's good to go. Step 2, test a single bucket creation. So we need to create a new bucket. We need a student ID. It will generate some random student ID for us. Export a bucket name. And then let's create a claim called single bucket.yaml. Let's paste in that here. And let's use the set command to update our new bucket with the name that we gave it. So this should, see if we can refresh that. That should have worked. Basically, this bucket name placeholder should update correctly. Maybe we're not in the right folder here. Single bucket.yaml, maybe I didn't write the name. Single-bucket.yaml. Well, let's check. Student didn't create anything. And that's probably why. And let's see. Bucket name. I'll have appsam. Oh, it's student ID, that's why. Student ID. There we go. And bucket name. So it does exist. So I'm not sure why the sed command didn't work. Let's run it again and see. Refresh that. Go back, come back. There it is. So it is there. We're good to go with the new bucket name. Let's apply that. So the bucket claim has been created. We can monitor that using this command here. Whoops, clear. Okay, it's not ready yet. There it is now. It's ready. Excellent. And we can check it like this. It shows us what we've got. The beta command, if you're interested in it, we can skip that. And once again, if we want to look at it inside of the AWS console, we can go to buckets, refresh, and there we have it. There's our new bucket. Okay, looks good. I already passed that. Where are we? Step. Okay, so we're done with the single bucket creation. Let's see how we can use an array to create a new bucket or a series of buckets. So let's run these commands here. This will help us create 3 buckets. As you know, we need a unique name for each bucket because these buckets are global in all of AWS. And that's why we're creating this student ID. And hopefully this is going to be unique. And create this file name in the manifest tab as multibucket.yaml. So this is going to be a new claim where we're going to use multiple buckets in an array. We'll call this multi-bucket. Create that and paste. And here, let's see what's happening. So team buckets, namespace backend team. These fields are required, but will be overridden by buckets array. So bucket name, that's fine. And here's the bucket array. So we give it a name, an environment, a tier, name, environment, tier. These placeholders will get updated here when we run these sed commands. So let's run that. Okay, if we come back here and just go out of the file and back, you see all that got updated for us. Let's apply the multi-bucket claim and check on that. Let's see. Team buckets true. Okay, let's stop that. And here we go. We've got our multiple buckets. So if we want to see that in AWS, once again, we can go back to buckets, refresh, and we will see the different buckets here. Here's dev 0, staging 0, dev 1, staging 2. That looks great. And just for fun, let's run the Crossplane beta command, beta trace command, and you can see how that all got created for us. But really the key takeaway here is that we are able to use functions in compositions and use them as pipelines and get much more complex logic, as we saw, that enables us to do a whole lot more than what just basic compositions give us. Welcome to episode 4. You've built an amazing platform abstraction. Developers love it. Now you need to share it across multiple clusters, version it properly, deploy changes safely, roll back when things break, and this is where Crossplane becomes enterprise ready. Let's see how we do all this stuff. We'll see in our first lab later, Crossplane package deployment, how we can bundle our platform, and we'll see that we can package it in terms of XRDs and compositions bundled together, provider dependencies declared, OCI compliant container images. We're going to see how to build a package with its directory structure, the crossplane.yaml metadata, and the crossplane x package build command. Then when we come to publishing, we can publish it to any registry really that supports OCI. In our demo, we're going to see how we're going to use the GitHub container registry, how to version tag it, and then you can see the package in that registry. And finally, deployment, we're going to install on a fresh Kubernetes cluster. We'll see our dependencies auto-resolved, and the platform is ready in minutes. Then we're going to move on to GitOps with Argo CD. And here in this lab, we're going to see how we can deploy the right way through Git. And the complete workflow here is basically we're going to commit a claim to Git, and then we are going to use Argo CD, so it will detect the changes, sync it to Kubernetes, and Crossplane will provision AWS resources, and everything is tracked in Git's history. Moreover, we'll see how we can promote from development to staging to production, same platform, but different configurations. We'll also see drift detection. We'll make some manual changes in AWS and see how Crossplane detects drift, and how Argo CD is going to show you out of sync, and we'll see automatic remediation. Now, for the business impact of what we're going to build, first off, for platform teams, we're defining standards once, enforcing automatically, no more ticket queues. For developer teams, things are simple. Declarative APIs are delivered, and all you need as a developer is to use the self-service portal for infrastructure, minutes instead of days to get the resources that you need. And for organizations, we get consistent auditable deployments, GitOps native operations, and multi-cloud from a single control plane. What we'll demo, first off, build and publish packages. Second up is setting up Argo CD for integration. Thirdly, GitOps deployment flow. Fourth, we'll see our environment promotion. And then fifth, we'll take a look at drift detection and remediation. Let's dig in. Okay, so we're in section 5 and looking at packaging and deployment. And we have a lab here, package and deploy crossplane compositions. And I've already run this lab or started it before recording, so we can get started right away. So entering the lab, and this lab has 2 tasks. The first one is that we're going to package our compositions, and the second one, we're actually going to deploy it. So let's get started. Step 1, we want to prepare our package directory structure. So first off, we want to run a few commands here. I can show you we have our crossplane system and get our namespaces. So we're on the crossplane system right here. And let's change our directory and take a look here. We've got this root crossplane. We have manifests, packages, and scripts. Let's check our AWS secret. It's right there. Now we can copy the XRD and composition that we built in the previous lab using our terminal here. So we're gonna, in this lab, we don't really focus on the actual compositions in the building. We just want to package them, right? So if you're interested in the previous labs of how we're creating XRDs and compositions, you can go there. So now let's take a look. We are inside the crossplane packages, and we have the database composition and database XRD. Now the configuration package content includes these components: the composite resource definition, the composition, and provider dependencies. And these are declared in the crossplane.yaml file. They're not separate files. So the way the provider dependencies work is, instead of including provider installation files directly, configuration packages declare the provider dependencies in this crossplane.yaml file. And when you install this configuration package, 3 things happen. Crossplane reads the dependencies from crossplane.yaml. It automatically installs the required providers, in this case, AWS EC2 and RDS, and applies your XRD and composition after providers are ready. So in runtime config, the provider configs, they're not included in the configuration package. Why? For 3 reasons. The first is security. Authentication credentials vary by environment. Second is flexibility. Different clusters use different auth methods. And separation of concerns. You want your package contains abstractions and not the actual runtime config. So then after the package installation, users have to apply the provider config separately with their own credentials and ensure that the provider config name matches what compositions expect. Usually default. In our case, it's default. So if you want to take a quick look at crossplane.yaml, it really is, there's 3 different pieces to it. The first is the package identity. So you can see name, annotations, and version constraints that might be there. And then dependencies, so provider dependencies, and then installation behavior. Crossplane reads this file first when installing a package, validates all the dependencies that are available before applying your resources. which ensures your proper installation is in the right order. So let's do that. Let's copy this and go into our packages tab, and under root crossplane packages, let's create a new file. And this file is going to be called crossplane.yaml. And in this file, let's go ahead and paste the crossplane.yaml configuration like this. And then step 3, let's build the configuration version. So back to the terminal, let's run the command crossplane version here. You can see our version. And then let's go ahead and build the package. So going into our packages folder and running the command crossplane x package build verbose, and you can see the output here. We can run the ls command to check, and yes, there it is. Now let's publish to our GitHub container. So for this, you need a GitHub personal access token. I give you the instructions to do that. I've already done this before the recording, so you can visit the GitHub settings page for a new token, give it a name and expiration, select the scope or scopes, generate that token, which we'll need in this step. So in this step, I went ahead and logged into Docker, but you can log into Docker using docker login ghcr.io, which is basically logging into GitHub's container registry. Put in your username and password, and then you just need to export this environment variable like that and put your username for GitHub. And let's change directory into our packages. We're already there. We have our GitHub username showing up nicely. Now let's run these commands to set the package details and push. All right, it looks like this has successfully pushed. And viewing our packages, we can do that by going here. Let's take a look. So here are our packages, and the package was called database abstractions. So it is right here, and you can see how we can pull it. Let's come back here and continue our journey. So we can optionally verify the package content. So we can do that. Let's run this command, and we can see the OCI container, the package contents. And it has a manifest.json, has a hash, and a tarball right here. If we want to see the actual YAML resources, we can do that as well. So we can change directory into that extracted package. And here is the package.yaml. And we can sort of quickly take a look at that. And here we go. We can see the content here. We have a configuration, a composition, and so on. All right, so that's our package. And now our package is ready for distribution. And like I said, there's a database claim API, which is an XRD. There's the AWS implementation, which is a composition, and then the provider dependencies. So with that, let's move on to the next task. And this is the deploying and testing our configuration package task. So over here, step 1, we need a fresh environment, and we need to verify that. So let's make sure that we have a fresh environment. Let's run this command, no resources found. Excellent. Verify AWS credentials are present. So let's run these commands, and all looks good. Now, step 2, create image pull secret for GitHub container registry. So we'll need to do that. So go over to the manifests tab. Under manifests and GitHub registry. So we need to create a new file here and call it GitHub registry secret.yaml. Create that. And to create the base64 encoded Docker config, first set your credentials as environment variables in the terminal tab. So go back here. Let's once again export our username. Then once again, let's put our GitHub token in here. Verify your variables are set correctly. Let's run this. All looks good. Now create the base64 encoded Docker config and update the YAML file. So we can run this, and this should update our YAML file here. If we do a quick refresh. Oh, we actually didn't run the set command yet, so let's do that first. You can verify by running this. There we go. So if we go here and refresh that, there it is. All right, apply the secret using the terminal. So let's apply our secret, and let's clear first, apply the secret, and we can verify it's there with kubectl get. Why image pull secret is required? Well, our GitHub container registry requires authentication for pulling packages. This image pull request allows your Crossplane package manager to authenticate and download your configuration package from your GitHub container registry. This is standard practice. Step 3, install configuration package. So we're going to need to create this configuration. So we're going to go over to our manifests tab and create a new file and call this file package installation. And we'll post or paste the configuration in here, as you can see. And here we got to replace your GitHub username. So we got to do that in here. All right. And the pull secret is correct here. So package, your GitHub container registry package, and which we created from task 1. And then the package pull secret references the image pull secret for authentication. Perfect. Now we install the configuration package by running the kubectl apply command like this, and we can monitor the package installation progress. Actually, we gotta wait till healthy is true, not just installed. So I'll give it a few seconds. And while we wait, what's happening is that Crossplane is downloading your package from the repo, from the repository's container registry. And then it automatically installs the AWS providers, EC2 and RDS from the dependencies. It installs your XRD and composition from the package. So everything becomes available for creating our claims. And there we go. We see that now it is healthy. So we can exit out of that. Control C. And now verify the package installation. So we can verify the components were installed correctly by running kubectl get XRD. Here we go. We've got our XRD. kubectl get composition. We have our composition, and check that the providers were automatically installed as dependencies. So here we go. We just need to wait a little bit more for EC2 to be installed. So we'll give it a few seconds here. All right, resuming the video here, you can see that now finally the provider for EC2 is up, installed, and healthy. Now let's go ahead and install the provider configuration, the runtime config. So we can run this command here. That is created, and we can verify. All right. And remember, this is what we said, that you apply this separately. It's not part of your package, which makes sense. Every environment is different, and we don't want to store any credentials anywhere. Step 4, test the complete package. So we can create a test claim now using the package composition. And let's create a file. Call it testclaim.yaml here in the manifests tab. So over to the manifests tab, create this claim. Let's copy our claim, put it in here, and you can see environment dev, size small, database name is test app. And we can go back to the terminal and create a new namespace for backend. And we're going to apply our test claim. And we can monitor the claim provisioning. All right, resuming here, we can see now that the database claim here is ready to go. So we can verify further, validating the package deployment success. So we can get the X database. You can see ready is true. And one of my favorite commands, I think you know by now, the beta trace, Crossplane beta trace command, which gives you the entire chain of events here. So if you run that, you'll see that everything is synced and ready. So all the different pieces that we need, the internet gateway, route table association, and everything else, all is ready, including the actual database instance itself. And of course, you can run kubectl get command for every single resource by itself. And the one that takes the longest is the RDS instance, which is done. You can also take a look at the secret for the connection. And you can see there's data here. See data 7. That means we have connection, including the database endpoint, host name, port, username, password, database name, connection string, additional metadata. So you can get this information, and the database team, the development team, in our example, will have that information to be able to log into RDS and start working with the database. Now you can verify this, of course, in the AWS console here. You can open an AWS, log in with these credentials, and you'll see the RDS instance, but we're not going to do that here. We want to move on to our next lab. Now let's move on to section 7, GitOps operations. Once again, I have started the lab prior to the recording so we can get started right away. But with this lab, we're going to learn about GitOps with Crossplane, specifically learning how to deploy and manage Crossplane infrastructure using GitOps principles and workflows with Argo CD. So let's enter the lab. And in the lab, we have 4 tasks. And the first task is to set up our GitOps infrastructure pipeline. Then we're going to see how to deploy an S3 infrastructure via GitOps, then GitOps environment promotion, and finally GitOps drift detection and cleanup. So I have gone ahead and run a few of these commands here. So first off, we're just verifying the Crossplane environment, that all is running, the AWS credential secret. And then I already installed Argo CD for GitOps. So you can see how we can just create a namespace Argo CD. And from here, we can run the script that will install it for us. And not only that, you can also grab the Argo CD password with this command here with the user admin, which we'll use to see the UI. We also have port forwarding set up, and we have this running through systemd. And now to access Argo CD, we can use admin here in this UI here. I'm already signed in, so I got admin signed in with the password that I just showed you. Step 4, configuring GitHub integration. So you can still use the same token we talked about in the previous lab for GitHub, export it here, and then you can store it in bashrc for the duration of this lab. Then create a GitHub repository using GitHub CLI. So GitOps is basically always relying on Git. So we're going to create a repo in GitHub where we're going to store all the manifests for Crossplane. So here walks you through generating a repo using the GHCLI. And if you already had the same repo because you ran the lab before, you can delete and create it again. Then configuring Git and getting your username, updating the remote URL, and then setting up the GitOps repository. So we're creating a bunch of directories and subdirectories and copying the provider and function manifests, copying the provider configuration manifest and the API manifests, platform API manifests, and then the application manifests. And then finally, we come to a tree. This is the proper repo that we're in. So running tree here gives us all the, you can see the application, development, production, staging, and I have a dev S3 bucket, dev S3, production S3, staging S3. And then under the infrastructure, you can see Crossplane, platform APIs, provider configs, and providers. So this is all, if you look at LL, we can see it's a Git repo here. So we can go ahead and add all the files here and then commit and push origin master. So now all this is now pushed into GitHub. All right, let's check and move on to the next task. In this task, we're deploying S3 infrastructure via GitOps. So begin the task. First off, we need to create an Argo CD application. So we can go over here and we need to create a file called Argo CD providers app.yaml. And we can put this in our manifests folder and create a file with this name. And let's copy our application manifest here for Argo. And as you can see, we need to change the GitHub username here to the one to mine. So update that. And now we can just apply. We also need to create an Argo CD application for the provider config. So do that as well. New file. And let's put the config in here. And once again, change the username to your username. And an application for the platform APIs. So let's do the same thing here. New file, create, put that in here and change this as well and apply. Now, did I actually apply it here? I'm not sure if I did. I might have missed this. Yeah, so we didn't apply this application. Let's go ahead and apply that. And then creating an Argo CD application for the development environment. So let's do that as well. Put that in here, change this, and go ahead and apply it. Now let's verify that the Argo CD applications are created. There's 4 of them. They're healthy. Good. Now we can check the Argo CD UI to verify that they're all in there. You should see 4 applications and they should be healthy and synced. So let's do that. There we are. 4 applications, all healthy, all synced. Excellent. You can also go back to the repo here. Okay, so that's step 1. Step 2, monitor the GitOps infrastructure deployment. So you can run this command here, and we can see that the AWS S3 bucket is there and healthy. We can also check functions. That is also ready, true, and healthy. And what else? Provider configurations, check that. We were just in the wrong namespace, so moving to the development namespace, we can see our provider config right there. Monitor platform API development, let's check that. X buckets is true, get composition, and it's there as well. So we relied on GitOps. Again, all we did was push into our GitHub bucket, create the applications for Argo CD, and now Argo CD is continuously monitoring our GitHub repo, and any changes it's going to update on our behalf, which is really the best way to do continuous delivery. All right, keeping on with the verifications here, kubectl get bucket claim, and in the development, it's right there, tier basic, and it's synced and ready. The XRD status, we can check that as well. It's right there. And finally, we can check our bucket. And there's our bucket, synced and ready. And we can also verify that the bucket exists by going to the AWS console, logging in. I already did that for us. And there it is. You can see under S3, there's the bucket and the name of the bucket, as we can see. You can also check a couple more debugging if you need to. We don't really need to, but I'll run it just for you to see. Crossplane beta trace to see all of that, and also the Argo CD sync status. You can run this to see exactly what we saw in the UI of Argo CD. Now let's test GitOps workflow updates. So test updating infrastructure through Git commits. What this will do is we'll make a change and see how Argo CD is going to reflect that change in the infrastructure. So navigate to GitOps repository. Let's do that. Make sure we're in the right path, which we are. And what are we going to do? We're going to change the development bucket claim to update the tier. So changing from basic to standard, let's do that. And then let's diff the change. You can see moving from basic to standard. Let's commit and push the change. Of course, you shouldn't be pushing directly to origin, whether master or main. You should open a pull request and do it the right way. And you actually have a branch, a feature branch, and then do a pull request and then merge into main and all that kind of stuff. But just to move quickly here for the lab, we're pushing straight to master. Now we can watch Argo CD sync the change, and it's pretty quick. It seems like it already did it. So we can get out of there. And then let's run this command, kubectl get bucket claim, and tier hasn't updated yet. So we just got to wait a little bit for the tier to change. See, Argo CD may take a few minutes to detect and sync the changes. If you're impatient, you can force that. I think Argo CD by default takes 5 minutes. So what we can do is we can go on the S3 development application, click the sync button directly. So let's do that. If we go to the S3 development application here, we can go in, you can refresh. You can see it went out of sync real quick and then it's synced. So this should already be synced for us. So we can go back and take a look. So if I run this command again, you see here now the tier has moved from basic to standard. Good work. So we saw here, it was continuous delivery in action. We didn't do anything other than make the changes in our code and then push that to Git and then let Argo CD monitor our repository and make the changes that we needed. All right, so this all checks out nicely. Let's move on to the next task here, GitOps environment promotion. So we're going to deploy staging and production environment using GitOps workflows with progressive security controls. So our first step is to deploy staging environment via GitOps. Once again, let's make sure we're in the right folder, and we're going to create a new Argo CD application for staging. So go to the manifests, create a new manifest, call it Argo CD staging app.yaml, paste the application in here, change your username, and let's apply that. Let's review it real quick. Okay, good. So here Reminds us that we're using tier standard instead of basic. Right here, environment staging, tier standard. Good. Now let's watch this. Here's our staging, synced and healthy. Very good. And now we can take a look at our staging bucket, and it's good to go. And we should be able to see that also in the UI, in the AWS UI here. So if you go back to here and refresh, and here we go. Here's our dev, and here's our staging bucket. Excellent. Now let's verify staging security controls. So again, these are verification commands that you can run. So check the tier. Tier is standard for staging. Looks good. View all environment tiers. So we can see here for the different bucket claims, we got the development and staging. They're both on standard since we moved development to standard, which we did in task 2. Production will have the premium tier when we deploy it. And then let's check the bucket claim environment configuration, run this command as well. And here you can see once again, the tier and the environment as well. So different commands to kind of get at the same thing here. Now let's go ahead and deploy our production environment with GitOps. So once again, we're going to create a new Argo CD application in the manifests file, a new manifests file, I should say. And then from here, let's paste this and change this to my username in GitHub and go ahead and apply it. Here, we're going to have the premium tier for the prod environment, as you can see. We can quickly take a look, see if this got deployed. Production is healthy, good. We can look at the bucket claim. That is done as well. We can compare all the environment tiers with this command. As you can see, they're all here. And then, again, if you're curious, you can see it in the buckets in the UI. You just need to refresh, and now we have dev, staging, and prod. Good stuff. All right. Let's test GitOps tag promotion workflow. Once again, let's make sure we're in the right path here. Let's clear. And let's update the development environment with the new project tags. So version 2 project launch, for example. So we're looking to change from platform version 1 to platform version 2 in the development environment, and also looking for the owner, changing DevOps team owner from DevOps to platform team. So let's do these 2 changes. And let's run a git diff to see the difference. So you can see the project moved from version 1 to version 2, DevOps team to platform team. So we're making the change in development first, in the development environment. And we're adding in Git. And we're committing, updating the development tags. And we're pushing. And upon this push, Argo CD should be able to sync. So we're probably going to be waiting for some time so we can force this. But let's first take a quick look here at the output. We're still on platform version 1 and owner is still DevOps team. So we want to speed things along and hit the sync button on the S3 development application. So let's do that. We're in the S3 development application. We can refresh. You see out of sync real quick and it's synced. So I don't really need to sync it again. So let's run this command once again. And there we go. We can see now project is platform v2 and owner is platform team, has changed from before. Once again, Argo CD did all the heavy lifting for us. Okay, so that's done for us. And now let's go ahead and take a look at the promotion piece. So far, we've done our changes. It's in development. It's running in development. We may have some tests along the way that we didn't show. But now we want to promote to staging. So make sure you're still in the right path. Let's make our changes now to the staging side of things. Commit and push. And once again, we can make that change or make the refresh, do the refresh in the staging application, which is down here. Refresh that, wait for it to sync. It already synced, perfect. And run this command. And we see now staging is also updated, project and owner. And finally, do the same thing for production. So we can run this, make the change, push the change over. And let me run this before we do the sync to show you the difference. So we're still platform V1 and platform team is the owner. So let's sync that as well over to the production application, run refresh. That's synced nicely. Let's move on back here, run this command again, and we should see now platform version 2 is running. So we followed the promotion technique here, moving from development to staging and finally to production. Okay, we can run this to kind of see the whole picture, and you can see the different bucket claims here with the different tags. We can see tier standard, platform v2, and we can actually verify that as well with this command. You can see platform v2 for all 3 environments. And there we go. We can see that production has tier premium as well. All right, though that ends this particular task. Let's find out what we have in our final task, where we talk about drift detection and cleanup. So we're going to test GitOps drift detection capabilities and clean up resources through GitOps workflows. Step 1, test GitOps drift detection. So let's get to the right folder. Identify resources to test drift detection. So remember, we've got our 3 buckets, dev, prod, staging. Now let's simulate configuration drift outside of Git. So test Argo CD's self-healing by manually changing the tier. Argo CD will automatically revert this change in less than 1 second. It's extremely fast. The best way to observe this is to watch the Argo CD logs in real time. Start watching Argo CD logs in the terminal 1. So let's do that. Here are the logs in terminal 1, and leave it running. Go to terminal 2 and run this command to patch the bucket claim. So remember, we're doing this outside of Git. We're doing this straight, a kubectl patch straight there. Watch the terminal 1 logs. You'll see the Argo CD logs showing detection of drift, application marked as out of sync. And it's really fast, hard to see, but you do see in the logs here, reconciliation completed, right? So it did happen. And if we jump back into terminal 2 and run this command here, we can see that it reverted back to standard. So we tried to change the bucket to tier premium in dev, and then Argo CD almost immediately, it was around 200 to 400 milliseconds that the sync already brought it back. So why so fast? We have this thing called self-heal is true, which means that there's immediate detection. Argo CD watches resources via Kubernetes informers, detects changes within milliseconds, instant reconciliation, self-healing triggers immediately, and not after that 3-minute or 5-minute reconciliation interval we saw before. So fast sync, no delay, and that's a good thing to reduce drift as much as possible. All right, let's keep moving on. And step 2, test rollback capabilities as well. So we make a change and commit it. So let's go here and let's make a change for the tags. And we're doing this in development. Let's take a look at the diff and immediately push. So the change is basically we're adding this tag test rollback demo. We already pushed that. Now wait for Argo CD to apply the change. And we're going to do our impatient sync ourselves here so we can go quickly. So this is the S3 in development, and you go ahead and refresh that. That automatically synced as well. Moving on. Okay, let's take a look now at the tags here. And where is our tag? Test rollback demo right there. Now let's go ahead and roll back these changes through Git. So git revert head and git push origin. So let's make that change rollback and go ahead and let Argo CD sync once again. Refresh. I'm back here and let's check it now. And there you go. We don't have test rollback anymore. It disappeared. Argo CD reverted back, and it all was controlled via Git. And Git is the source of truth. We can do rollbacks, we can make changes, and Argo CD just follows what we have in Git. We can also clean up our resources in Git, and the way to do that is to delete the application itself in Argo CD, because if you do that, then that will take care of it for us. So delete production, delete staging, delete development. We can now clean up our bucket claims manually as well. And this is also something we can do. We can see these buckets in here, so we can go ahead and delete all. So this will cause Crossplane to delete the underlying AWS S3 buckets, remove the X bucket composite resources, and remove finalizers. and clean up everything for us. So let's see if this is already done. Looks like it is done. We can also remove some infrastructure components as well. The applications for Crossplane, provider configs, platform APIs, and verify the cleanup. All looks good. If you wish, you can also delete the GitHub repo in case you want to rerun this lab in the future as well. So we can do that also. And with that, congratulations, we've completed this lab. Welcome to episode 5, and we're going to talk about the evolution of Crossplane with version 2.0. Let's talk about the complexity that version 1.x brings, and really it's this claim XR split. Remember claims? Where you create a claim in your namespace, it creates a cluster scoped XR, which creates the actual resources. Configuration happens in one place and then status in another. Crossplane 2.0 eliminates this split entirely, and not only that, there's a few more things we'll get to. But realize that a developer creates a namespace scoped claim in version 1, then platform creates cluster scoped XR, then resources spread across 2 objects, and then now your troubleshooting requires checking both. So like I said, it's too complex. Version 2.0 fixes that. Version 2.0 introduces a major simplification. We're moving to namespaced composite resources, XRs. In version 1.x, you had to manage, like I said, a claim and a composite resource separately. That's 2 objects to keep track of. But now with version 2.0, it's just 1 object. The old pattern required cluster scoped XRs, which made troubleshooting a lot more complex. And the new pattern is namespaced scoped, which makes debugging a lot easier. Think of it this way. Instead of claims, create XRs, create resources, we now have XRs that create resources directly. The namespace scoping is the key change, and it fundamentally simplifies how you interact with and manage these resources. True multi-tenancy means isolation. Each team only sees their own resources in their namespace. So Team A queries their namespace and sees only their databases. Team B does the same in their namespace. This is a major improvement. Previously, cross resources with XRs were visible cluster-wide, which created visibility and security issues. Teams now won't accidentally interfere with or even see other teams' infrastructure. This namespace-based isolation is cleaner and more secure than the old approach. Version 2.0 isn't just about simplification, it's also about making Crossplane a complete platform automation engine. We have 2 main operation types in Crossplane for platform automation. First up is Cron operations. So these schedule workloads like backups, cost optimization, daily backups using cron operation, weekly cost analysis. And then the second one is watch operations that allow you to create event-driven automation, monitor resource changes, automatic responses, allow for scaling and alerts. Together, these make Crossplane a complete automation engine. So you're not just managing infrastructure, you're orchestrating intelligent, responsive workflows across your entire platform. Version 2.0 compositions can create any Kubernetes resource, not just cloud infrastructure. So one claim can now create DynamoDB tables for infrastructure, config maps, which is configuration, secrets, connection details, network policies, which is security, pod disruption budgets, which is reliability. You're not building infrastructure platforms anymore. You're actually building complete application platforms. In our demo today, we're going to first compare version 1.x and 2.0 patterns. Then we're going to see how to deploy a namespaced XRDs and then create multi-tenant resources, followed by implementing cron operations and building a complete platform stack. We're now in section 8, and the lab is called Crossplane version 2.0 Migration Lab. I have the lab already set for us, so let's get started. And in this lab, we've got 3 tasks. We're going to convert claims to namespaced XRs first. Remember, there are no claims in version 2.0, so we'll see how to move from that. Then the second task is implementing a database operations workflow, and then finally some advanced version 2.0 composition patterns. All right, so first step is to compare version 1.x versus version 2.0 patterns. So to do that, we can go ahead and cat these 2 files. So this is a reviewing 1.x claims complexity. So you can see here the first file is a database claim, and the second file here is the database XRD. And we want to notice here how, from a complexity perspective, the pattern is that it requires developers to create a namespaced scoped claim that would create a cluster scoped composite resource. So the flow is the developer creates the claim, and then the platform is going to create a composite resource, and in turn, XR manages the resources. So the problem is we've got a resource split, troubleshooting complexity, and multi-tenancy challenges, kind of what we saw in the slides. All right, so step 2, let's go ahead and deploy version 2.0 namespaced XRD. So let's run it first. So that got created. And then let's verify the namespace configuration. So we can do that by running this command. And you can see it is namespaced right here, confirming that version 2.0 has this multi-tenant capability. And if we want to dig deeper and take a look at this file, right? This file is v2 database XRD. And here you can see scope is namespaced, right? That's what we were looking at when we ran the command here in the terminal to specifically look at the scope in the spec. What the scope namespaced now does, it allows developers to create resources directly. So no split now between claim and XR. It works in their namespace, true multi-tenancy. They get to see all the information in one place, so allows simplified troubleshooting as you would expect. Now, step 3, let's create a multi-tenant database resource. First, we'll examine Team A and Team B's database YAML files. So let's go to the manifest file. Team A, you can see here, it's namespace database XR for Team A. Here's the namespace scoped, and secrets will stay in that namespace. And for Team B, the only difference again is the namespace here. Excellent. Let's go ahead and apply those two manifests. Create first one, create the second one. Step 4, let's verify the real AWS infrastructure creation. So we want to make sure that we've actually created AWS DynamoDB tables and provide true multi-tenant isolation. So we'll jump in and take a look inside of the Team A namespace first. And we see here production DB. And then in Team B's namespace, we also have its own database. So we got production in Team A and analytics in Team B. And if we want to check all namespaces so we can see them both at once, you can see them right there. All right, let's check the real DynamoDB table creation and run this command. And that is already created. We can describe it to get more details about it. And then once again, my favorite data trace command we can run. And notice here, this is where the note tells us that the ready status for X database resource can show ready false, even though the underlying DynamoDB tables are successfully created with ready true. This is expected behavior in Crossplane version 2.0, when compositions include regular Kubernetes objects like secrets alongside managed resources. All right, so let's go ahead and check the status of this task. It's successful. Let's move on to our next task, which will implement database operations workflows. So we'll explore Crossplane's version 2 operations capability and see that in action. Let's go ahead and get started with step 1 here and verify operations framework. So first up, verify operations are enabled. So let's take a look at our kubectl API resources. We've got cron operations, and watch operations. So they're all ready to go. Now let's configure operations RBAC. And first examine this manifest file operations RBAC.yaml. And this config provides the necessary permissions for operations to manage database resources and execute operational workflows. So you can see here, it's of kind role. The team A is the namespace and operational permissions. You can see real Crossplane version 2.0 operations API and so on. So it takes some time. You can go through this file. Let's go ahead and apply this in the terminal. So let's see, it created a database operations. So these are all created roles and role bindings. Step 2 is to deploy scheduled database operations. So let's create automated backup and cost optimization workflows that run on some schedule. So let's examine the database backup cron job here, database backup cron.yaml, daily database backup cron operation using Crossplane version 2. So you can see it's of kind cron operation. And then here's the alpha version right now. Here's a cron schedule. And here the operation template defines what operation to run. So basically at 2 a.m. UTC, we're going to run this daily. And what it does is it's scheduled, as you can see, daily at 2 a.m. It targets the production DBX database in the Team A namespace. And the actions that we have here, it would trigger DynamoDB backup with 30-day retention and encryption, cross-region replication. So you can see a lot of this down here. Notifications would send success failure alerts to platform teams and Slack. Automation eliminates manual backup processes and ensure compliance. So you can see now we're moving beyond just provisioning with Crossplane into more maintenance work, as you just saw. All right, let's move on and deploy this. And then finally deploy cost optimization operations. So we can check the cost optimization cron. And this one scheduled, as you can see, runs weekly on Sundays, 3 a.m. Targets all database resources in Team B namespace. Here's Team B. And from an actions perspective, it will analyze usage patterns, recommend right sizing, identify unused resources. Optimization would automatically apply approved cost optimizations, such as resizing a table, adjusting provision capacities, and so on. And of course, reporting would generate cost reports and savings recommendations for the finance team. So let's go ahead and apply that and move on to step 3. And here we're going to create a watch operation that monitors a DynamoDB performance in response to capacity issues automatically. So let's examine the DynamoDB monitor watch.yaml file. DynamoDB, it's actually database monitor watch.yaml. Kind is watch operation. Once again, it's in alpha. Namespace Team A. Let's see what this does. Watches all X database resources in Team A namespace for specification changes. So here's our watch. Triggers when database storage or performance requirements change. Here's the operation template. So we can see this would create a monitoring event when database changes. In production, this would trigger capacity scaling or alerts, meaning that it will automatically scale DynamoDB capacity, adjust read-write units, configure auto-scaling, and so on. And then from a monitoring perspective, it's going to collect performance metrics, send alerts if some of the thresholds were exceeded. Self-healing would automatically respond to capacity issues before they impact applications. Okay, let's go ahead and implement or apply this. And now we can get all of our operations deployments running this. And here we go. We've got the cron operations and the watch operations right there. Step 4, test operational automation. So we're going to test everything we just did. So let's go ahead and run this command to check events. And now let's update a database resource to simulate capacity changes in the terminal. Now let's check the events again. And we can see here an additional event got created. Reason updated external resource. Here's the table for the DynamoDB successfully requested update of external resource. So what this simulates in production is a change would trigger the watch operation to detect the storage increase and automatically adjust your DynamoDB table provision capacity, update auto scaling policies, and reconfigure monitoring thresholds and so on. So, all right, so we ran this command earlier and we saw the updated external resources. Now we have the composed resources on the X database production DB responded. So in a real operational production environment, you'll also see operational events, scaling events, monitoring alerts, and so on. So as a task summary, we saw how we're able to see beyond just Crossplane creating or provisioning resources. Now it's touching scheduled maintenance, event-driven responses, self-healing the infrastructure, and operational intelligence as well. Let's go ahead and move on to the next task. In this task, Advanced Version 2.0 Composition Patterns, we're going to explore Crossplane's capabilities to compose any Kubernetes resource not just infrastructure, as we talked about in the slides. So we're building complete application platform stacks that include monitoring, configs, and operational tooling alongside your database infrastructure. All right, let's get started with step 1 here. And we're going to first apply an advanced composition. And this composition is going to have database, monitoring, configuration, operational components. It's a pretty complex one. Let's take a look at this in the manifest file here, advanced database composition. So let's see what's in here. We've got kind composition. And in here, we've got the Modus pipeline. And we've got multiple steps, creating resources. Here's a DynamoDB table. There is an application config map. So notice we're building actual Kubernetes resources as well. Here's a secret, config map, network policy, and a pod disruption budget as well. And that's really the point here is not only are we creating actual resources in AWS, we're actually creating some Kubernetes resources as well. So there's the database infrastructure for DynamoDB, that's infrastructure resource, and then 4 Kubernetes resources here as well. So let's go ahead and apply this. And then step 2, let's deploy the application platform XRD. So create the XRD that defines the API for our complete application platform, not just the database. We can examine this here under app platform XRD. So notice again, it is scope namespaced. Here's the database configuration, the application configuration, monitoring configuration. This is all new in version 2.0, security configuration, reliability, and so on. Okay, that looks good. Let's go ahead and apply that. Let's verify the XRD establishment and scope. Condition met. This is done. Perfect. Check the scope again. Should say namespace. We already examined that in the manifest. Step 3, deploy the complete application. So create a complete application platform that demonstrates version 2's capability to compose any Kubernetes resource. And we'll do that by first examining the production app platform.yaml file. Let's see what we got here. Production application platform, complete stack, got an XApp platform here in Team A's namespace, database infrastructure config. You can see storage 100 gig, transactional, retention in days. We have application platform config. We got the monitoring and observation. We have security and compliance, and we got reliability and availability. All of that is ready for us in this file, so we can go ahead and apply that. And of course, we can verify that as well. Of course, we got to give this some time. Let's see how far we got. Check the table. It's ready. Perfect. Let's verify all platform resources. So what do we got here? We got the config map, the secret. We got the DynamoDB table, the networking policy, and the pod disruption budget. All is created for us. With version 2.0, once again, we're creating Kubernetes resources alongside infrastructure resources. And finally, if you're interested to check the AWS Console, you can always go here, open in AWS Console and log in. I've already done that. And you can see the DynamoDB table is right here for us, all set and ready to go. So we're good with that. And again, task summary, we've seen how we can build a complete platform stack in Crossplane version 2.0, all with Kubernetes resources like config map, secrets, network policies, pod disruption budgets, in addition to real infrastructure like DynamoDB tables, all supporting components for the application deployment all in one place, which is super powerful. And I'm excited about this feature, and I hope you will be as well. Finally, if you'd like to dig deeper, check out our comprehensive Crossplane 101 course. It's designed to take you from beginner to proficient in platform engineering with Kubernetes. The course covers the complete workflow you need to master. Start with a Kubernetes cluster setup and AWS provider integration. Learn how to build and work with compositions and XRDs, which are the core building blocks. Move into packaging, deployment, and GitOps operations, and get up to speed on migrating to Crossplane version 2. Here's what you're getting. Over 15 hours of video content to learn at your own pace, 7 hands-on labs where you'll apply what you've learned in real scenarios, a certificate upon completion to validate your expertise. And we stand behind this course. You'll have a full 30-day money-back guarantee, so there's no risk in getting started. Thanks for watching.